Yes, sir.
Okay, in previous class, we calculated the moments for a two-way slab system from the moment coefficients given in the tables. And now we will transfer the load of slab to the surrounding beams. Of a two-way slab system. Okay. Now, since you are familiar with the load transfer mechanism of a one-way slab system, so for example, if there is a one-way slab system consists of two panels like this, this is the shorter side which is represented by LA. Okay. Now, for example, the interior beam along the longer direction is B1 and the exterior beams are B2. Similarly, the exterior beam along the shorter side, it is B3. And the ultimate load of slab is represented by small w u. If you want to calculate the load acting on B1, W V1. So you can calculate it very easily. You know that half span load will transfer from one panel and half span load will transfer from the other panel. So this will be equal to WU into LA by 2 into 1 plus, because this distance, this is LA by 2 and this distance is also equal to LA by 2. So this is from one panel and plus WU LA by 2 multiplied by 1. This is from the second panel. Okay. And this one is the coefficient because all the load is transferred along the shorter direction. So we take the आवाज आ रही है?
Yes, sir.
Yes, sir, was clear.
Clear. सही. Since we assume that in a one-way slab system, all the load will be transferred along the shorter direction. So that is why this coefficient here, this is equal to 1. And this coefficient is represented by WA, load transfer coefficient along the shorter direction. This is represented by WA. Okay. Similarly, if you want to calculate the load acting on B2, so can you calculate the load acting on B2? Load acting on B2 will be how much? Quickly, Shabash.
So LB half, sir.
WU LA by 2 multiplied by 1. Simple, you know. Half load transfers to this beam and half load will transfer to B2. Correct? And again, this coefficient is 1 because it is the load transfer along the shorter direction. Now, what about the load acting on B3, this beam? Can anyone tell? Load acting on B3.
सर LB2 लेंगे सर इधर.
Anyone else? Load acting on beam B3. It is a one-way step system, okay?
तो सर 0.
0 होगा सर फिर.
0 होगा. So, if we write it in a general form, this will be equal to WU into LB divided by 2 multiplied by basically this coefficient will be 0. And this coefficient is represented by WB. So it means that the load transfer coefficient along the shorter direction is 1 and the load transfer coefficient along the longer direction is 0. And why it is 0? Because it is a one-way step system and there will be no load transfer along the longer direction. That is why load acting on B3 will be 0. Clear? कोई क्वेश्चन है इसमें?
No sir.
No, sir.
अच्छा, now for example, suppose it is a two-way step system. LA LB divided by LA is less than 2, for example. So now what about this coefficient WA? If it is a two-way step system, then what will be the value of this WA? It will be
Less
greater
than
than 1, less than 1, or equal to 1?
Less than 1.
Less than 1. Of course, WA will be less than 1. Why? Because now some of the load will also transfer along the longer direction. Okay? And what about WB? Load transfer coefficient along the longer direction. It will be 0 or it will be greater than 0.
Greater than 0.
Yes, it will have some value. It will be greater than 0. So this is how you can calculate the load acting on the surrounding beams of a two-way slab panel. Okay, you have to first of all calculate these load coefficients, and from these load coefficients you can calculate the load acting on the beam. This lecture में, this was the summary of this lecture. इस लेक्चर में हम क्या करेंगे? Load transfer coefficient tables given है, and there is only one table for this load transfer along the shorter direction. WA will be calculated from the table, and from WA you can calculate this WB1, WB2 और WB3 भी आप calculate कर सकते हैं because WB will be equal to 1 minus WA. So WA you will pick it from the table, again from the same shorter to longer span ratio and from different boundary conditions. The WA values will be given. and then WB can be calculated from WA using this relation. Okay. Clear?
Yes, sir.
Now coming to the same example again. This was the example which we started to solve in the last class. यहाँ पर ये एग्जाम्पल इसकी जो डेटा है ये ज़रा नोट करें. Slab is given as 7 inch, column size is 14 by 14 inch, and beam size is 14 by 20 inch. Okay. And the total load acting on the slab is calculated and it is equal to 0.336. तो ये जरा नोट करें अपने साथ. Beam size is equal to 12 by 20, 14 by 20 inch. Total weight acting on the slab is equal to 0.336 hit per square foot. Now from this you can calculate the clear length along the shorter direction, which will be equal to L is equal to center to center length is given here. It is 20 feet. So 20 minus width of the beam, 18 by 12. It is coming 18.83 feet. And LB is equal to 25 is the center to center minus 14 by 12. So 23.83 feet. From this you can calculate M. So M is equal to LA divided by LB. ये जरा कैलकुलेट करें शाबाश. 18 by 8 divided by 23. ये वैल्यू बताएं शाबाश.
0.79.
18.8. 0.79, so almost equal to 0.8. So the in value is 0.8, and for different boundary conditions, the shorter direction load transfer coefficient will be given. So again, it is panel 1. This is panel 1, panel 2, panel 3, and this is panel 4. Okay. So first of all, we will calculate the load acting on this beam, which is basically B1. Okay.
Yes, sir.
And load acting on this beam B2. So for these, we need two coefficients, WA for panel 1 and WA for panel 2. Okay. Now coming to this table, panel 1 corresponds to which case? This is panel 1. Two sides are continuous and two sides are discontinuous. These are the
केस 4 है
tension.
सर.
Case 4. So M is equal to 0.8 and this is case 4. So what is WA value?
0.71.
0.71. तो यहाँ पर लिखे 0.71. Okay. And WA for panel 2 is how much? First of all, panel 2 corresponds to which case?
Eight, nine.
8 सर. 8.
Case 9. No, it is case 9 because the shorter side is discontinuous. Okay. A value it is 0.83 is equal to 0.8. Okay.
सर ये इसमें लॉन्गर साइड डिसकंटिन्यूस नहीं है सर.
पैनल 2 में शॉर्टर साइड डिस्कंटिन्यूस है यार, आप देखें ना.
ओके सर. सॉरी मैं 3.
This is panel 2. सही. चलिए पैनल 3 के लिए भी कैलकुलेट करते हैं. WA for panel 3. It is corresponding to which case?
वो 8 नंबर.
Case 8.
8. So the value will be 0.55. Correct? Clear?
यस सर.
Yes, sir.
So it is 0.55. And finally, WA corresponding to panel 4. Okay. So panel 4 corresponds to which case? This is panel 4.
Two.
Huh? Case 2, yes. Because all sides are continuous. So this is the coefficient value, 0.71. Okay. So WA for panel 4 is equal to 0.71. Now we can write all these coefficients here. WA for panel 1 was equal to 0.71. WA for panel 2, it was equal to 0.83. WA for panel 3, it was equal to 0.83. Sorry, 0.55. And WA for panel 4, again it was equal to 0.7. Correct? Now coming to load acting on B1. So load acting on B1, some of the load will come from panel 1 and some of the load will come from panel 2. इस तरह है कि नहीं?
Yes, sir.
तो ये दोनों हम ऐड करेंगे. तो W E1 will be equal to WU W from panel 1 plus W from panel 2. From panel 1, the load will be equal to WU LA by 2 multiplied by its coefficient. So coefficient is 0.71. Correct? Plus WU LA by 2 multiplied by coefficient, which is 0.83. Okay. तो इसकी वैल्यू जरा पुट करें 0.336. LA is how much? 18.83 divided by 2 multiplied by 0.71 plus 0.336 multiplied by 18.83 divided by 2 multiplied by 0.83. तो ये जरा वैल्यू कैलकुलेट करें शाबाश. Load acting on B1.
$4.87.
4.871. Okay, perfect. This is the load acting on exterior span of B1. Okay, this is basically exterior span of B1. Now, load acting on interior span of B1. For example, I am representing it with green color. This is basically the load acting on interior span of B1. अगर उससे पहले हम कैलकुलेट करेंगे लोड एक्टिंग ऑन P2. तो लोड एक्टिंग ऑन B2 ऑलरेडी हम कैलकुलेट कर चुके हैं. This load, sum of load is coming on this beam and some will on this beam. So B2 will be equal to WB2 is equal to WU LA by 2 multiplied by WA of panel 1. This is equal to 0.336 multiplied by 18.83 divided by 2 multiplied by 0.71. ये ऑलरेडी हम यहाँ पर कैलकुलेट कर चुके हैं यहाँ पर. तो ये जरा कैलकुलेट
2.246.
2.246 kip per foot. This is WB2. Correct? Now coming to the load acting on the interior span of B1. This span. So some of the load will come from panel 3 and some of the load will come from panel 4. तो इससे आप कैलकुलेट कर सकते हैं. Again, this is WB1, but this is the interior panel. This will be equal to WULA by 2 multiplied by WA from panel 3 plus WULA by 2 multiplied by WA from panel 4. Okay. तो ये जरा पुट करें 0.336 multiplied by 18.83 divided by 2 multiplied by WA of panel 3 is how much? It is 0.55. And for panel 4 it is 0.71. So it is 0.55 plus 0.336 into 18.83 divided by 2 multiplied by 0.71. So how much is the load?
Three point 985.
3.985 kip per foot. This is the load acting on interior span of B1. Okay. यहाँ तक clear है? Now coming to the load acting on interior span of B2. For example, if it is represented by this blue line. तो ये भी ऑलरेडी हम कैलकुलेट कर चुके हैं. Load acting on this side from panel 3. This is basically this load, okay? So W B2 of interior panel, this is equal to WU into LA by 2 multiplied by WA of panel 3. तो ये ऑलरेडी हम यहाँ पर कैलकुलेट कर चुके हैं. सही, ये जरा कैलकुलेट करें शाबाश. 0.336 multiplied by 18.83 divided by 2 multiplied by WA, which is 0.55. कैलकुलेट करें शाबाश.
One point seven three.
1.79
74.
1.74.
1.74 kip per foot. वेरीफाई करें शाबाश. 0.336
Yes, sir. 1.73.
1.74. सही. Okay. So if you see these spans, they are same. They are the two interior spans. You have already calculated load for these spans, and these exterior spans are also same. So it means that you have basically calculated load on the full length of this beam, okay, of these two beams. And similarly, you can see that these beams, these two beams are same. This is also B1, and this beam is also B2. So it means that you have calculated the load acting on all beams running along the longer direction. इस तरह है कि नहीं?
Yes, sir.
तो अगर आप इसको इस पर प्लॉट करें तो it will look like this. Load acting on this beam, it was equal to how much? 4.875 4.871. Similarly, load acting on B2 exterior span, it was 2.246. Load acting on the interior span of B1, it is 3.985. And load acting on the interior span of B2, it is 1.74. is 1.74. अगर आप देखें ये दोनों beams both spans are same. This is 3.985. यहाँ पर again this is 1.74 and these spans are same, so this is 2.246. These two spans are same, so 4.871. And similarly these two beams are same, B1 and B1, and these exterior beams are also similar. तो यही वैल्यूज आप इसके लिए भी रख सकते हैं 4.871, 3.985, 3.985, 4.871. सिमिलरली ही वैल्यूज यहाँ पर भी लिखें 246, 1.74, 1.74 and 2.246. So what does it mean? It means that you have transferred the load from slab to the beams running along the longer direction. We have calculated the load on all beams running along the longer direction. Okay. अब इसके साथ आपने ऐड करना है it is basically the load coming from the slab. The total load will be equal to this load plus the self weight of the web. इस तरह है कि नहीं? आवाज आ रही है?
यस सर।
जी सर आ रही है।
अच्छा, बस इसके साथ अब आप
Yes, sir.
सेल्फ वेट ऑफ द वेब भी आप इसके साथ ऐड करें। व्हाट इज द क्रॉस सेक्शनल एरिया ऑफ द वेब? द बीम क्रॉस सेक्शनल area was equal to 14 by 20 inch if you remember, and slab thickness was equal to 7 inch. So what will be the depth of web?
$13.
13 inch. So cross-sectional area of the web, this is the self weight of the web. It is equal to cross-sectional area, which is 14 by 13 divided by 144 multiplied by 0.15 and multiplied by 1.2. This is the self weight of the web. You have to add this value to all these values. Okay. ये कैलकुलेट करें शाबाश। What's the value?
0.2275.
0.2275 almost equal to 0.23 hip per foot. So you have to add this value with all these values to calculate the total load acting on these beams. Okay. फिर जरा आप ऐड करें शाबाश, ताकि हम वही वैल्यू लेके 0.23 ऐड करें 4.871 के साथ।
5.101.
5.1, तो यहाँ पर हम लिखेंगे 5.1। इसके साथ ऐड करें 3.985 प्लस 0.23
4.215.
4.2 सही। 1.74 के साथ ऐड करें
1.97.
1.97 और इसके साथ ऐड करें
2.476.
2.48 almost. ओके, तो ये वैल्यूज हम मिटाएंगे बिकॉज The total load acting is now this one. So this is equal to 1.97, 2.48, 4.22, 5.1, 5.1, 4.22, 4.22, 5.1, and similarly 2.48, 1.97, 1.97, and 2.4. Okay. So these are the loads acting on the beams running along the longer direction. Okay. इसको अगर हम ड्रा करें इसकी सेक्शन ड्रा करें तो this beam, for example, B1 will look like this. Okay, so load acting on this span and these exterior span, they are equal, and load acting on the interior span are also equal. Load acting on the exterior span is greater as compared to the load acting on the interior span. And what was the value? It was 5.1 kip per foot. 5.1 kip per foot. Load acting on interior span. How much was the loading? 4.22. Okay. So the load acting on the interior span is 4.22 kip per foot. Clear? यहाँ तक कोई क्वेश्चन है? Any question? Any question?
No, sir.
No, sir.
Now you can analyze the same beam using a coefficient method. The coefficient values, you know that for exterior column support it is 1 over 16 negative moment. Negative moment at this face is 1 over 10, is 1 over 11, 1 over 11, 1 over 11, 1 over 10, and 1 over 16. Similarly, positive moment coefficients, they are for exterior span it is 1 over 14, for interior it is 1 over 16, 1 over 16, and 1 over 14. And you know that the clear span length is 23.83. All these clear span length they are equal, and they are equal to 23.83. Okay. WU value for each span is also given. For exterior spans it is 5.1, and for interior span it is 4.22. So WU Ln square for each span you can calculate, and you can analyze the beam. Similarly, using shear coefficient, you can calculate the shear values, shear force values at all the supports. Okay, clear?
Yes, sir. Clear.
Similarly, if we draw B2, beam B2, it will look like this. Okay. And again, load acting on the exterior span load acting on the exterior span was how much? 2.48, and load acting on the interior span, it was 1.97, 2.48, 1.97, and this load is 1.97 hip per foot, and this load is equal to 2.48 hip per foot. And again, in the same way, you can analyze the given beam using SA coefficient method. And once you calculate the moment and shear values, the design is same. You can do the design in the same way using the same procedure. Okay, clear? Any question?
No, sir.
Now coming to the load acting on the beams running along the shorter direction. Okay. So now we have already calculated the coefficients for the shorter direction for each panel. So from these coefficients, we can also calculate the coefficient along the longer direction. These are very simple. WA for panel 1 is equal to 0.71. WA for panel 2 is equal to 0.83. WA for panel 3 is equal to 0.55. And WA for panel 4 is equal to again 0.7. So now can you tell me the value of WB for panel 1? What is the value?
0.29.
1 minus 0.71. So it is equal to
0.29.
0.1. Similarly, WB for panel 2.
0.17.
It is how much?
0.17.
0.17.
0.17. Sorry. It is equal to 0.17. Okay. Similarly, WB for panel 3.
0.45.
0.45.
0.45. WB for panel 4.
0.29.
0.29. So coming to Again, the same plane. Now, load acting on the beams running along the shorter direction. For example, this is now beam 3 and this is beam 4. Okay. And if you analyze these two beams, so we have analyzed all the beams in the short direction because this is also equal to B3. Again, this is B3. Then B3. Okay. This is sorry B4. So now we will delete these values and we will calculate the load acting on these beams. B4, B3, B3, and B4. So first of all, load acting on B4 and B3. Okay, exterior panel of B4 and B3. Okay, so this load will come from panel 1. Correct? So very quickly we can calculate the load coming from panel 1. So this will be equal to WU into LB divided by 2 multiplied by WB of panel 1. इस तरह होगा ना? So what is the value? WB of panel 1 is 0.29. तो हमारे पास this is 0.336 multiplied by LB is 23.83 because now this is the load transfer along the longer direction. WB for panel 1 is 0.29 and divided by 2. These are calculate करें शाबाश.
1.16.
1.16. So 1.16 will be written here. And it will also be written here. Okay. Similarly, load acting on the interior panel. This load will come from panel 2. This will be equal to WU LB divided by 2 multiplied by WB of panel 2. ये भी calculate करें शाबाश. 0.336 multiplied by 23.83 multiplied by WB of panel 2. How much? It is 0.17. This is 0.17 divided by 2. ये value जरा बताएं शाबाश.
0.68. 0.68.
0.68 and similarly 0.68 will come here. Similarly, load transferred from panel 3 to B3 beam, it will be equal to how much? Very simple. WU LB divided by 2 multiplied by WB of panel 3. ये जरा कैलकुलेट करें शाबाश. 0.336 multiplied by 23.83 multiplied by what is WB for panel 3? What was the value? 0.45 I think. Divided by 2. You calculate करें शाबाश.
1.80.
1.80 will come here and 1.80 will come here. Okay? Similarly, load transferred in the longer direction from panel 4. It will be again equal to 0.336 multiplied by 23.83 multiplied by what was the value of WB for panel 4?
0.29.
0.29 divided by 2. How much is the
Yeah,
value?
1.16. 1.16.
1.16 here and 1.16 here. Okay. तो बेसिकली इसमें हम क्या करेंगे कि 1.16 for interior beams we will add these two values to get the total load. Okay. और ये अगर आप देखें because these panels are similar तो यहाँ पर भी हमारे पास होगा 1.8 यहाँ पर भी 1.16. ओके क्लियर है यहाँ पर it will be 1.8 1.16 similarly 1.16 यहाँ पर भी आएगा 1.16 यहाँ पर भी यहाँ पर हमारे पास है 0.68 1.16 So now you can see that basically you have calculated the load on all beams running along the shorter direction. Okay? बस इसमें एडिशनल आपने काम ये करना है ये जो फॉर इंटीरियर बीम्स ये लोड्स आपने ऐड करने हैं because some of the loads are coming from one panel and some of the load is coming from the other panel. Okay? तो इंटीरियर पैनल के लिए ये लोड्स ये प्लस करें. क्लियर. और उसके साथ इन सब वैल्यूज के साथ आप सेल्फ वेट भी ऐड करें. एंड व्हाट वाज द वैल्यू ऑफ सेल्फ वेट ऑफ whip? It was 0.23 kg per foot. ओके तो चले मुझे जरा वैल्यू बताएं शाबाश. ये हम नेक्स्ट इसका एक और डुप्लीकेट ले लेंगे. ये ऐड करें शाबाश. इंटीरियर स्पेन के लिए जो वैल्यूज है ये ऐड करें और इनके सब के साथ 0.23 के पर फुट भी ऐड करें. तो मुझे यहाँ पर टोटल वैल्यूज 1.16 प्लस 0.23 तो कितनी वैल्यू है? आवाज आ रही है?
यस सर 1.39.
1.39.
1.39. तो यहाँ पर हम लिखेंगे 1.39. ओके अच्छा 1.16 plus 1.8 plus 0.23. इसकी वैल्यू बताएं शाबाश।
3.19.
3.19
3.19.
3.19 है ना? अच्छा, इसके साथ ऐड
Yes, sir.
करें 0.23, 0.68 प्लस 0.23,
0.91.
0.91। अच्छा, ये ज़रा ऐड करें 0.68 प्लस 1.16 और इसके साथ 0.23 भी ऐड करें।
ये 2.07.
2.007, so almost equal to 2.1 kip per foot. तो बाकी तो आपको पता है, these both spans are similar, so this is 1.39 again. These two spans are similar. This is 3.19. Okay. This is B4. This is B3. So now B3 and B4. You calculated the total load acting on B3 and B4. तो बाकी भी वही वैल्यूज हैं 3.19, 2.1, 3.19, 3.19, 2.1, similarly 1.39, 0.91
सर
and
सर ये तीसरे पर जो आपने
जी
वैल्यू लिखी है चेंज नहीं होगी सर?
सर मिड वाली बीम पे चेंज होगी।
जी जी
मिड वाले बीम पे सर ये चेंज नहीं होगा?
कौन से वैल्यू की बात आप करें?
सर ये मिड पे, ये जो B1 B2 B3 जो आपने लिखा है मिड पे, ये चेंज नहीं होगा सर?
हाँ बिल्कुल, ये चेंज होगा, बिल्कुल एग्जैक्टली ये चेंज होगा। ये वैल्यू जरा बताएं मुझे।
ये सर 3.83 है एक्सटीरियर पे, 3.83।
मिड वाली बीम पर चेंज होगा फिर कितना आ रहा है?
3.83।
3.83। ये 0.23 भी आपने ऐड किया ना
यस सर,
इसके
यस
साथ?
सर।
यस सर, यही है 3.8।
So this is coming 3.83. This is also 3.83. And what about the interior span value? ये
2.55।
दोनों ऐड करें 2.55 is equal to 2.55. So now basically these are three types of beams: B4, B3, and this is B5. Clear? Because loading on this beam is different. Clear है ना? Hello?
यस सर।
आवाज आ रही?
यस सर, आ गई।
So this beam is now different from the other beam. So this is B4, B3, and B5. Again, this will be B4. Oh, sorry, B3, and this is B4. Okay. So very simply, you can analyze now this beam, and once you get the values of moment and shear, then you can design it also. Okay. So here for if I draw this beam, for example, B4, it will look like this. This is B4. Okay. The exterior span and the interior span loading. What are the values? 1.39 and 0.91. This is 0.91 kip per foot. And this is 1.39 kip per foot. Clear? So again, using the same coefficient method, these coefficients are 1 over 16, 1 over 10, 1 over 11, 11, 1 over 10, 1 over 16. These are the negative moment coefficients, and positive moment coefficients are 1 over 14, 1 over 14, and 1 over 16. So in this way you can analyze, you can calculate the moment and shear values, and then you can design the beam yourself. Okay, यहाँ तक कोई confusion है, कोई question?
नो सर।
No, sir.
अच्छा, इस स्लाइड्स में भी आप देख सकते हैं, यहाँ पर हम डायरेक्ट आते हैं, ये मोमेंट कोएफिशिएंट तो आप ऑलरेडी पढ़ चुके हैं। यहाँ पर आप आ जाए, B1 बीम आप देखें, पर लोडिंग टेबल यूज हुई 0.83, आप देख सकते हैं द लोडिंग इज बेसिकली 5.17। अच्छा, यहाँ पर हमने एक गलती की है, ये दिस इज बेसिकली द सेंटर टू सेंटर लेंथ। ओके, और हमने वहाँ पर यूज़ किया था क्लियर लेंथ। ओके, तो यहाँ पर आपने सेंटर टू सेंटर लेंथ देनी है, सही। You can see these values. Finally, values अगर आप देखें, these will be same. ये values slightly larger than ours because they have taken the center to center length, and you should also take the center to center length. Okay. Analysis of beam B1 आप देखें जरा, exterior beam B2, analysis of beam B3, B4, and यहाँ पर है design of beams, do design of beam yourself। तो ये आप खुद देखें और फिर इसकी डिज़ाइन भी आप खुद करें, सही है। एक ब्रेक लेते हैं, फिर उसके बाद ये प्रॉब्लम we will quickly go through this problem। इसमें ये सारे आप ऑलरेडी पढ़ चुके हैं, but we will just quickly go through it in the slide। ओके, तो 10 मिनट का एक ब्रेक लेते हैं, सही।
सर एक क्वेश्चन है सर।
Okay, can you see the slides?
Yes, sir.
So this is design example 2, which is design of a 3-story commercial building, and we will analyze the only one floor of this building. Covered area is 100 by 60 feet. Data is given here. Interior properties: FC prime 3 KSI, FY 40 KSI. Slab thickness is 7 inch. Column size is 14 by 14 inch and beam is 14 by 20 inch. Coming to the load, so superimposed dead load is 0. There is no superimposed dead load. Self weight is thickness of slab multiplied by unit weight, 0.0875. Live load is 144 psi. So ultimate dead load is 0.0875 multiplied by 1.2, so it is coming 0.105 kSIP. And ultimate live load is 0.144 multiplied by 1.6, so it is coming 0.2304. And 0.105 plus 0.2304, the total ultimate load is 0.336 kSIF. Why we need ultimate dead load and ultimate live load separately? Can you tell me?
इसको सेपरेट कैलकुलेट करना है सर.
And because for positive moment calculation, we need separate dead load and live load values. Complete analysis of the slab is done by analyzing 4 panels. ये ऑलरेडी हम डिस्कस कर चुके हैं. Panel 1, 2, 3 and 4. First of all, we will calculate M. So M is clear length in the shorter direction divided by clear length in the longer direction. It is 0.78, so almost equal to 0.8. So for panel 1, these are the coefficient values: CA negative, CB negative, CA positive for dead load, CB positive for dead load, CA positive for live load, and CB positive for live load. Okay. So from these we can calculate the moments. These are the moment values. MA negative 8.44 foot kip. MB negative is 5.52 foot kip. MA positive 5.37 and MB positive 3.57. Similarly, panel 2, it is corresponding to case 9. CA negative, CB negative, CA positive for dead load, CB positive for dead load, CA positive for live load, and CA positive for live load. Again, using the same equations, you can calculate the moment values. And these are the moment values. MA negative, MB negative, positive, and MA positive and MB positive. Panel 3, which corresponds to case 8, and for this, these coefficient values are given. You can see here. And from these coefficients, you can calculate the moments. These are the moment values. And finally, panel 4, for which corresponds to case 2 basically. And for this, the coefficient values are given here. And finally, the moments calculated are given here. So if you draw these moments on these 4 panels, you can see that the common support between different panels. For example, this support is common between panel 1 and panel 2. So one negative moment value will come from panel 1 and other negative moment value will come from panel 2. Clear? So which one will be picked for the design? दोनों में हम कौन सा लेंगे?
8.91 greater.
8.91 will be taken for the design. Similarly, you can see the common support between panel 2 and panel 3, panel 4. So one value will come from panel 4 analysis and one from the panel 2 analysis. So 5.4 will be taken for the design. Okay. Similarly here, This value is coming from panel 3 analysis. This is from panel 4 analysis. So maximum of these two, that is 7.72, will be taken for the design. Similarly, in this case, now what about these values? The negative moment, where from these values are coming? A discontinuous end. If you remember, I told you that negative moment at discontinuous end are taken as 0 in case of two-way slab analysis. The negative moment at discontinuous end is considered as 0. तो फिर ये वैल्यू कहाँ से आ गई?
1/3 लेते हैं.
1/3 of this moment. For example, 5.37 divided by 3 आप करें, so you will get this value. Similarly, 3.57 divided by 3 अगर आप करें, so you will get this value. Okay. Similarly, 2.82 divided by 3 आप करें, so you will get 0.94. Okay. Now, how to design the slab? So again, the same way. First of all, you will calculate the minimum reinforcement. For number 4 bar, the spacing is 15.89. Maximum spacing allowed is 14 inch or 18 inch because 2 inch is the maximum spacing requirement for 2-way slab system. If we use, for example, number 4 at 12 inch center to center, so for 12 inch spacing, the area is 0.2 inch square. Corresponding to 0.2 inch square, if you calculate the compression block depth, it is 0.26 inch. And if you calculate the moment capacity corresponding to minimum reinforcement, so it is 3.37 foot cube. Now, if this capacity is greater than the demand moment values, so in those regions you can provide number 4 at 12 inch. And for other values, for example, if the demand moment values are greater than this value, then for those values of moment you can calculate the spacing, okay, from trial and error. So if you see, these are the positive moment along the longer direction. First of all, we will discuss the positive moment along the longer direction, which means that the bottom reinforcement given along the longer direction. So if you see, the capacity coming from number 4 at 12 inch, it is 3.37. Okay. And all these values, they are closer to this value. They are less than this value or closer to this value. So what does it mean? It means that number 4 at 12 inch will be sufficient in the bottom reinforcement along the longer direction. Using number 4 at 12 for all positive movements in longer direction. Okay. You clear it? The question is में आवाज आ रही है? हेलो?
यस सर आवाज आ रही है. समझ भी गए सर, इजी है.
सही. Now coming to the positive movement along the shorter direction. So you can see these encircled value, they are the positive movement values along the shorter direction. तो अब इसके लिए आपने डिजाइन करना है. So if you see, these are the 4 values and the maximum value is 5.37 foot cube. For this, if you calculate the design reinforcement from trial and error, to find the design reinforcement is coming 0.32 inch square and for number 4 bar the spacing is coming 7.5. So as all the moments are almost same, we will use number 4 at 6 for all the above moments. ये clear है?
Yes, sir.
Now coming to the moments, the negative moments at discontinuous end. इसका क्या मतलब है? इसका मतलब ये है कि in the bottom you will provide number 4 at 6 inch along the shorter direction and number 4 at 12 inch along the longer direction. Clear? So this along the shorter direction will be number 4 at 6 inch. And along the longer direction, the force will be number 4 at 12 inch. Clear?
Yes,
Now
sir.
coming to the top reinforcement. First of all, the negative moment values at discontinuous ends. You can see all these values are less than 3.37 foot cube, which is the capacity coming from number 4 at 12 inch. So it means that at discontinuous end along the shorter as well as along the longer direction, you can provide number 4 at 12 inch spacing. Clear? So in the top at discontinuous ends, number 4 at 12 inch spacing is sufficient. Now coming to the negative moment at interior supports along the shorter direction. Okay, so these are the values. You can see these values. These are the negative moments at the interior supports along the shorter direction. These are the 4 values you can see here. Now, if we take this maximum moment and we design for this moment, so the reinforcement coming is 0.55 inch square, and for number 4 bar the spacing coming is 4.5 inch center to center. So it means that the top reinforcement at interior support along the shorter direction is number 4 at 4.5 inch center to center. Clear? Any question?
No, sir.
Now, negative moment at interior supports along the longer direction. You can see that the negative moment values at the exterior span and the negative moment value at the इंटीरियर स्पेस। इसमें अगर आप देखें 7.8 and 5.52, मिक्सिमम ऑफ दीज टू इज 7.8, तो इसके लिए हम डिज़ाइन करेंगे। इसमें 3.24 and 5.14, मिक्सिमम ऑफ दीज टू इज 5.14। अच्छा, अभी अगर 5.14 आप देखें तो इसके लिए ऑलरेडी हम कैलकुलेट कर चुके हैं स्पेसिंग, तो इट इज़ नंबर 4 at 6 cm, and 7.8 is almost equal to 8.91, तो 8.91 की करस्पॉन्डिंग जो स्पेसिंग हमने कैलकुलेट की है वो हम प्रोवाइड कर सकते हैं यहाँ पर। ओके, so this is the final drafting plane of reinforcement. You can see A is showing number 4 at 12 inch spacing, B is showing number 4 at 6, C number 4 at 4.5 inch. Okay. The yellow color is showing the reinforcement along shorter direction, and white color shows reinforcement along the longer direction. You can see that the bottom reinforcement along the shorter direction, it is number 4 at 6 inch, is B, and bottom reinforcement along the longer direction is A, it is number 4 at 12 inch. Also, the top reinforcement at discontinuous ends is also A, which is number 4 at 12 inch. Okay. Top reinforcement at interior support along the shorter direction, it is C, which is number 4 at 4.5. Top reinforcement along the longer direction at interior support, it is B, which is number 4 at 6 inch. And top reinforcement along the longer direction at exterior span, it is C, which is again 4.5 in center center. Okay, clear? Now if we draw a section on this slab, section AA. So how will it look like? ये हम ड्रा कर सकते हैं. चलिए आप खुद ट्राई करें. दिस इज ए क्लास एक्टिविटी. सेक्शन ए ड्रा करें. शाबाश. You have only 5 minutes. Draw section A. Shabash. Quickly. Okay. So this is section A. The bottom reinforcement given along the shorter direction, it is at number 4 at 6 inch, if you remember. And this reinforcement will be given closer to the bottom face, as you know. This is number 4 at 6 inch center to center. Okay. Similarly, the bottom reinforcement along the longer direction, it will be denoted by these dots. And the spacing is number 4 at
सर जी क्वेश्चन है मेरा एक
G. Any question? Similarly, the top reinforcement at discontinuous end. This is the top reinforcement at discontinuous end. It will be curtailed at L by 4. And the spacing of top reinforcement at discontinuous end, it is number 4 at 12 inch. Center to center. Now coming to the top reinforcement at the interior support, which is C. It is number 4 at 4.5. And it will be curtailed at L by 3. And the spacing is, you know, it is number 4 at 4.5 inch. Okay. And of course, the supporting bars at 18 inch. Normally go at 18 inch center to center. These are the supporting bars. So the spacing of supporting bar is number 4 at 18 inch center to center. Correct? Okay, what will be the difference between section A and section B bottom reinforcement? कोई बता सकता है? सेक्शन बी भी इसी तरीके से फिर आप करें, मगर ये ज़रा बताएं कि what will be the main difference in the bottom reinforcement. अगर हम सेक्शन बी को ड्रा करें तो बॉटम reinforcement जो है इसमें क्या डिफरेंस होगा, कोई बता सकता है?
ये बॉटम वाले जो हैं ये अब डॉटेड शो होंगे और जो डॉटेड शो यहाँ पर हुए हैं वो लॉन्गिट्यूडनल.
Yes, exactly. So now the blue line, you can see the blue line as dot bars. Okay, and the yellow dots, they will be represented as a line. Okay, तो ये डिफरेंस होगा, बाकी आप खुद करें, सही है? So this was all about the slab design. Now the load of the slab will be transferred to the beams. Already हम कर चुके हैं. We will just quickly go through it in the slides. और फिर beams को इसके लिए डिजाइन करेंगे, सही? So this is the load transfer. We are transferring the load from slab to the beams. First of all, V1. These are the coefficients. WA panel 1, WA panel 2. And as I told you, this L will be center to center length. So this is basically B is 20 feet. These are the coefficients. These are the values. And the load coming on B1 is 5.17 kip per foot. ये हम डिटेल में ऑलरेडी कर चुके हैं, सही?
Yes, sir.
Similarly, load on this beam B2 along the shorter direction. These are the coefficients, and WB can be calculated for these coefficients. This relation 1 minus WA, and these are the values. You can see.
एक्सक्यूज मी सर
जी
सर हमने ये फर्स्ट जो एग्जांपल तो इसमें सर हमने फर्स्ट बीम को डिजाइन किया और अब स्लेब को कर रहे हैं सर। पहले तो ऐसा नहीं होना चाहिए कि पहले हम स्लेब को डिजाइन करते हैं और फिर बीम को करते हैं।
नहीं, आप फर्स्ट स्लेब ही को डिजाइन करेंगे, मगर ये दिस वाज न्यू टॉपिक टू यू, इसलिए मैंने लोड ट्रांसफर समझाने के लिए पहले मैंने बीम का किया।
ओके, थैंक यू सर, थैंक यू सर।
Now you can understand it, that how the load is transferred from the slab to the surrounding beams. Okay, these steps अब आपको ऑलरेडी आपको पता है, ये स्टेप्स सारे, ये वैल्यूज हैं, इनको प्लस करें इंटीरियर के लिए। दीज आर दी वैल्यूज, उसके साथ सेल्फ वेट ऑफ द वेब के साथ ऐड करें। दीज आर दी वैल्यूज नाउ, और कोफिशिएंट मेथड से आप इसको इस तरह एनालाइज कर सकते हैं। सो यू कैन सी एनालिसिस भी ऑलरेडी गिवन है। दिस इज B2, exterior beam B2, interior beam B3, exterior beam B4, and finally, because moment and shear values are given to you, तो आप क्या करें, to design आप beams yourself, तो ये आप खुद डिजाइन करें शेयर के लिए भी और फ्लेक्जर के लिए भी। अब आप कर सकते हैं ना?
जी सर, इंशाल्लाह हो जाएगा।
Now these are some pictures from a multi-story commercial building. Different stages of building construction. You can see a video here. तो बहरहाल ये वीडियो आप खुद देख सकते हैं, इसको हम शेयर करेंगे। दिस इज प्रैक्टिस एग्जाम्पल, वही एग्जाम्पल है जो पीछे हम पढ़ चुके हैं, स्पेस भी हुई है, बट द लोडिंग कंडीशन एंड स्लैब थिकनेस इज डिफरेंट। सो यूजिंग दीज लोड वैल्यूज यू विल एनालाइज द सेम स्लैब सिस्टम। ओके, तो इस पर आप प्रैक्टिस करें। Now, this is another practice example. Design the given slab system. In this case, the panel dimensions are 20 by 15 feet. And then the summary. If you have any question, you can ask the question. This is the last lecture before midterm. Okay,
मिड टर्म में सर यहाँ तक आएगा?
यहाँ तक आएगा.
सर
जी जी.
ये स्लाइड्स में सर एनालिसिस गलत हो सकते हैं सर?
हाँ, ये आप कंफर्म करें ना, हो सकते हैं बिल्कुल.
सर लेक्चर 2 की एनालिसिस मैंने सर शेप से भी की है और मैनुअली वो गलत आ रहे हैं.
नहीं, शेप और उसमें तो फर्क आएगा ना. वो
शेप और मैनुअली सर एक जैसे आ रहे हैं, लेकिन स्लाइड में जो है वो गलत है.
तो ज़रा नोट करें और शेयर करें. समीउल्लाह टीए के साथ शेयर करें. अगर उसमें कोई हो तो हम अपडेट करेंगे, और ये भी हो सकता है कि हमने गलती की हो.
सर मैंने एक और दोस्त से भी करवाया है उसको सर, उसने भी कहा कि ये स्लाइड्स होने वाले थे.
तो ये ज़रा समीउल्लाह के साथ शेयर करें. सही.
ओके सर.
सर ये उन्होंने कहा था कि अभी ये स्लाइड्स अपडेट हुए हैं, पिछले में कुछ गलतियां हो सकती है, अभी अपडेटेड में उसको करेक्ट किए.
तो अपडेटेड ज़रा देखें, फिर उसमें भी अगर गलती हो तो फिर हमारे साथ शेयर करें, हम देखेंगे. सही.
एक्सक्यूज मी सर.
जी जी.
सर हम असाइनमेंट लेट सबमिट करा दें सर, क्योंकि मिड्स भी हैं, तैयारी करनी है सर.
तो आपकी तैयारी हो जाएगी ना.
तो सर मतलब दूसरे सब्जेक्ट्स भी है ना, और थोड़ा सा डिफिकल्ट है. अगर हम थोड़ा लेट सबमिट कर दें तो.
तैयारी की क्या है यार, तो आपको मेरे ख्याल में 10 दिन है आपके पास.
रिकॉर्डिंग ऑफ कर ले.
एनी क्वेश्चन?
एक्सक्यूज मी सर.
जी जी.
सर टाइम थोड़ा एक्सटेंड करें ना सर.